Okay, I left off on page 185 after those examples at the top. This was example 1. And for those of you with the textbook, let me just go ahead and put these numbers in so you can keep up with what we're doing. This is page 185, example 1. Okay, the next thing I want to tell you about is going to involve a table of values. So I want you to draw this with me. We're going to be doing this a lot. That's why I think the graph paper is really helpful. Let's put 6 columns. I'm sorry, 6 blocks in a column. And here's another one. And then let's draw a line. There's 1, 2, 3. I got too many, didn't I? 4, 5, 6, 7. It's okay, we'll use it. So we know that this is the x column, this is the y, but in function notation, this is x and this is f of x. We know that this is the domain and that this is the range. So these are all headers. I'm just giving you a vocabulary review here. Nothing new, we're just reviewing what we've already covered. Okay, so here come the values. 1 and 2, 2 and 4, 3 and 6, 4 and 8. So first of all, let's decide if this is a function. And to do that, you have to look at your x's and look to see if any of them are duplicated. There is no duplication. So yes, this is a function. Okay. So if you have a table of values, the easiest way to tell if you have a function is what I just did. All right, let's draw another table, but let's leave some space in between. 1, 2, 3, 4, 5, 6, 7, 8. Whoa, didn't mean to do that. Meant to do this. Okay, so this is just a review of the terms. X and Y. X or f of x. You can use f of x instead of y. This is the domain, the input, and this is the range. And here come the values. We have -1, 4, 0, 0, 1, 4, 2, 8. So here is just the header with the labels on it. We need to decide yes or no, is this a function? So let's look at our x values, see if anything's duplicated. There are no duplicates, no repeats. So yes, this is a function. So both of these pass the function test. Both of them are functions. But I want to show you something very interesting about these two, or to me it's interesting. In this first example, let's focus right here just a minute. Let's go ahead and map the function, and that just means you're drawing an arrow to the output. Okay, this is called mapping the function. This is called a one-to-one function. put it over here. And let's see if we can figure out what that means. This is a one-to-one function. Okay, let's look at this one and let's do the same thing. Let's map. This is not a one-to-one function. It is a function. It passes the function test in the X column, but it is not a one-to-one function. So let me pull these side by side and see if you can tell me the difference. So here they are. They're mapped out. The one on the left is one-to-one. The one on the right is not. So why? What is it about the one on the right that means it's not one-to-one? It's right here. You see how that 4 is duplicated? It's allowed. It's still a function if it's in the right column. But it's not one-to-one because both x of -1 and x of +1 are connected or mapped to y equals 4. The 4 is used twice. In this first example, nothing is used twice. It's all different. It's all a different value linked to the x's. So the definition of a one-to-one function is this. We know if it's a function, it has to be a rule. But what is the definition of a one-to-one function? A one-to-one function is a function, a rule, in which every domain value, now let's stop, which one is domain? Is that x or y? That's x. Every x value has a different range, which is the y value. So if a one-to-one function is true, there are no duplicates anywhere. If it's not one-to-one, you can have different duplicates in the y column. Okay, let's stop this video and I'll meet you back.